Here it is. Find the particular solution given the general solution. So remember, the general solution is the one that's given to with the C values, right? Generally speaking, after you integrate, there's a plus C, and that would be known as the general solution. Now, that C is often found by plugging in some initial conditions. Now, because this is a second derivative, right? That means we have to go back twice, backwards. We have to go backwards twice at, or forwards, depending on actually which direction. In this case, they give us the particular. So I'm going to, well, actually, they give us this. I'm going to start with this guy, okay? So I'm going to start with the fact that, no, I'm going to start with my second derivative here. Sorry, my first derivative. Because my first derivative is going to have a single C value in it, all right? So you can do that in either way. You can either take this here and integrate it, or you can even differentiate this one right here, right? So I don't know if you can see that, but yeah, you should be able to. So you can even differentiate this right here. And so that's basically what I'm going to do. All right. So I'm going to take my derivative here. I'm going to say that y prime equals -2 cosine x, because the derivative of sine x is cosine x, plus a. All right. And now, this is my second derivative. So now I'm going to take this and I can say, all right, look, my second, sorry, I keep saying second derivative. This is my first derivative. My first derivative is equal to -2. So -2, right? When I evaluate it at pi over 2. So I'm going to write myself a -2 cosine pi over 2 plus a, allowing me to find a. So that's kind of cool because I was able to replace this and this. I can now find a. A is, let's see, I guess we're going to figure out the cosine pi over 2. So we'll go pi over 2's here. Cosine is, this coordinate is x coordinate 0, y coordinate 1. And so therefore my cosine of pi over 2 is going to be 0. So there we go. We got a is -2. That's nice. Now, what are we going to do? Now we got our general solution here. It's ready to go. We got a general solution of y equals -2 sine x a, but we already discovered a. A is -2. So it's plus a. So I'm going to write -2x plus b. And now we just have this b hanging out here. That b we can find because now I know that when I evaluate y at pi over 2, I get a 0. So I'm going to get a 0 there. And I'm going to evaluate this guy at pi over 2 minus 2 pi over 2 plus b. Now, I already have the sine of pi over 2 here, which is going to be 1, right? So this is going to be 0 equals -2 times 1 minus, these 2's cancel, I guess. So I'm going to get a pi there plus b. So I'll add those guys over, and it looks like I'm going to get a b is equal to, add my pi over, add my -2 over, so it's going to be 2 plus pi. Like that. Now, so therefore I've got my a, I got my b. So my general solution is my particular solution is going to be y. Here it is. Sorry. Here's the general solution. I'm going to take it and I'm going to rewrite it. But instead of writing a, I'm going to write -2, so minus 2a, x, sorry. And instead of writing b, I'm going to write 2 plus pi. So plus 2 plus pi. And I don't know where that one is. It should be in here somewhere. I think this is it. -2 sine x. Here it is. There. And by the way, these answers are not, these gray answers, when you see them, they're not necessarily the correct answer. I just kind of randomly chose just to get a, just to complete the quiz there. All right. So in fact, I think they're all wrong. So determine the function, sorry, determine which function is a solution to the differential equation. All right. So here, I'm gonna do, probably just gonna do like a plug-in. All right. So each one of these is equal to y, right? I'm gonna kind of imagine it like this. This is equal to y. And when I take this y and I plug it in here, and then I take its derivative of this one and I plug it in there, I should get a true scenario. So I'm gonna kind of just plug some things in, right? Now you can kind of see if you're good at this, this is something plus something else. It's got to equal 0, right? So we're going to have some kind of negative popping out of here somewhere because these two guys are going to have to cancel. All right. So one of these things has to be negative either on this side over here or in this one. So I can look at these and think about, okay, which derivative is going to produce a negative? This is the only one. So this one really is my only candidate. And then if that one doesn't work, then none of these, right, would be the proper answer. But for just for fun, I'm going to check this one first. All right. So if that's y, right, then y prime is 2e to the 2x. Okay. Now I'm going to take this x times y prime, which is 2e to the 2x. And then I'm going to add to it 2y. Well, y is e to the 2x. And if this is equal to 0, all of this stuff, then this is the correct answer. Now you can kind of see that this is obviously not going to be equal 0. So this does not equal 0. So that's not the correct answer. This one isn't going to work either. But so let me check this one. The way I do this, I'm just going to write each of these out. So my y prime in this case is going to be a negative 2x to the negative 3. Okay. And so that's going to be nice because it's going to give me exactly what I need, I believe. So I'm going to take my x, I'm going to put my y prime in there plus 2 and my y in there, and hopefully it equals 0. So again, my y prime is a negative 2x to the third. Where does that one go? That one goes here, negative 2x to the negative 3. And my regular y is just an x to the negative 2. And if you remember your exponent rules, an x here and a negative 3x turns out to be a negative 2x. So this simplifies to a negative 2x to the negative 2 plus a 2x to the negative 2, which does equal 0. Hey, look at that. And so therefore I've got a solution. All right, let's move on to this one. dy. If dy over dx is cosine squared pi y over 2, and it looks like they give us some kind of initial condition here. So y is 0.5, x is 0. Find the value of x when y equals 2.5. All right. So this is number 4. I suppose I'll use, I guess what I'm going to use here is separation of variables. All right. So I'm going to take this guy and I'm going to rewrite him with a separation of variables here. Now, this part's going to be maybe a little tricky. So I'm going to divide this cosine. I guess yeah. So I'm going to write, how do I write this so that it makes, let's see. What I'm doing is I'm multiplying by 1 over cosine squared, and then there's a pi y over 2. Hopefully that's not too small. Maybe I'll erase that and make it a little bigger. Pi y over 2. There we go. And this is equal to, okay. And oh, I'm leaving the dy over there, dy. Dy. And then this is going to be equal to, so I'm going to pass my dx over. And what's left over here? Just a 1. All right. So what ended up happening is this guy got divided over here and my dx got multiplied over there and it left just a 1. Okay. And I guess we don't really need that arrow. It's pretty obvious we're going that direction. Now, question is, now what do I do? All right. Well, now what you do when you do your separation of variables is you integrate both sides. Boom, like that. Now you got a nice, beautiful little integral here. But then you might be thinking, oh man, what's the integral of 1 over cosine squared? So you might want to check your integration tables. But this one's tricky because it's actually going to be secant squared pi y over 2. And then this one is just going to be 1 or just dx, I guess. All right. So now, how do I integrate secant squared of pi y over 2? All right. I'm going to make a u substitution. I'm going to say u. Oh, that's a highlighter. I don't want that. Somebody buzz me. It might have been my phone. All right. Here, let me erase that. So I'm going to make a u substitution here. I don't know if you guys can see that. Let's do this. U substitution of pi y over 2. Okay. Now I'm going to, oh, I forgot my dy here. Ah, man. I'm sorry, guys. I'm bumbling through this here. dy. So I'm going to multiply my 2 over and divide by my pi. That way I get 2u over pi equals y. Now I'm going to differentiate both of these guys, okay? And so it looks like I get, I guess that's a constant, 2 pi, right? So I'm just going to get a d here. I'll write it over here. No, I don't need to write it over there. I'll write it here. So I'm going to get 2 over pi du equals dy. So there's my dy. So it's just going to be a 2 over pi du. So I'll make that. And then I'll put a u in here. All right. So my integral of secant squared of u du. And then I'm going to put a 2 pi out front. So the 2 pi goes in there and the du goes in here because the dy gets replaced by the du with that out there. And now the integral of secant is tangent, right? So 1 dx. Now I'll do each of these integrals. So this is just going to be x. All right. There's x. Now, question is, what's the integral of this? So it's 2 over pi. The integral of secant squared u is tangent u. So tangent of u. But remember, u is pi y over 2. Pi y over 2. There, we did that. Oh, and don't forget plus c, because this is a general solution. General solution. Now I can find the particular solution with these givens up here. And then I'll probably have to reevaluate it at 2.5. When y is 2.5, solve for x, okay? I knew I didn't want to use all this space over here. That was a problem. Let me move this stuff, see if I can move. Oh, no. I can't. I'm just going to erase this, use substitution. I think you guys got that. All right, so now what I'm going to do is find the particular solution. So I'm going to write a 2 over pi tangent of pi y. Y is 0.5. We're going to write a 1/2. 1/2 over 2 equals x, or 0, plus c, right? Because I put x as 0 and I put 2 here. Sorry, 1/2, right? So now this is going to be pi over 4, right? Tangent of pi over 4 is 1, okay? So we're going to get 2 over pi, and that's going to be times 1 equals c. Okay, that's kind of cool. So here's my particular solution now. Same thing. Particular solution is 2 pi tangent of pi y over 2. I'm going to leave that y out. X plus 2 over pi. Like that. Okay. Oh, I lost my camera. Hello? You guys still there? Start video. I think I lost video. I don't know if I'm on video now. General webcam. I don't know. Doesn't matter. Hopefully you guys can still see the screen record. I hope. Oh no, video's back. There it is. Hey, there we are. Okay. Here we go. So what are we doing now? We're putting the pi as 2.5. So 2.5, I guess, is 5 over 2. 5 over 2. And so it's going to be 5 pi over 4. So it's going to be 2 pi tangent of 5 pi over 4 equals x plus 2 over pi. Oh boy, so tangent of 5 pi over 4 is a -1, okay? A -1. You remember that one? So it's 5 pi over 4 is here, and the ratio of, no, it's a positive one. It's a positive one. There it is. It's a positive one. It's a good thing I drew that out, because my coordinates for 5 pi over 4 are √2 over 2, √2 over 2, both negative. So therefore, the tangent of this is the y coordinate divided by the x coordinate. And so since they're the same, it's a 1. So this is a 1, okay? Let's see where we can go with this. So it's 2 over pi times 1 equals x plus 2 over pi. Those 2 over pi's cancel. How exciting is this? And looks like x equals 0. Look at that. Hopefully I got that right. I didn't check this answers or anything like that beforehand, so I should have maybe, I guess, but I feel like that looks okay. Let's go with that. There. All right, so x is 0. Let's solve this differential equation here. Okay. And let's see. What we're going to need to do for this one is, again, I believe, a separation of variables. So I'm going to pass this y down. I'm going to multiply the 8x up here. Okay. So I'm going to get my y down. So I'm going to go with 1 over y dy equals 8x root of 4x squared minus 1 dx. And there, separation of variables, bang, differentiate both sides. Sorry, I meant integrate both sides. And we end up having a nice little, attractive little integral here. So here's my integral. This one's going to be nice and easy. It's just going to be the natural log of y. This one, I'm going to have to make, again, a u substitution. For this one, I'm going to notice that it looks like the derivative of this is here, right? Because look at this. The derivative of this whole thing is here. So that's going to be a nice little u substitution. I'm going to let u equal that thing, 4x squared minus 1. And then I can say that du equals 8x dx. All right. And there, now we have the 8x dx, which is this pink stuff here and here. You can see those two. Those get replaced into a du. And then I get simply this as my integral. The integral of the root of u du, right? And now there. Is that what we got? I think that's what we got. Now, this one is just going to be the integral of 1 over y dy. The integral of this guy is a half here, so I'll increase this by 1, right? And let's see here. Got my dx's, all right, looking good. So I'm going to increase the half by 1, so I'm going to get a 3/2. Oh, my pen. My pen got messed up. Sometimes when I do that, I got to cancel. And, oh, here, let me get rid of some of this stuff. And I'm going to cancel and relaunch. Okay. So there we go. Oh, okay, there we go. So I'm going to go u to the, oh, it's still broken. U to the 3 over 2, it's sticking. And then I'm going to multiply by 2, divide by 3 over 2, so it's actually going to be 2 over 3, like that. How's that sound? Pretty good. This one here is going to be natural log of y. There. Man, I'm sorry, guys. I'm having some technical difficulties with my devices here. Equals. There we go. Okay. So now we're like, oh, shoot, man. So I got to solve for y. All right. But then there's this plus c hanging around. Uh-oh. What are we going to do with the plus c? So it could be none of these. Could be one of these. It could be something along these lines. You know, this one doesn't even have the plus c. So I wouldn't necessarily go with that one. So the question is, where does the plus c go? It actually goes right here, plus c. All right. So now what you're going to do here is you're going to solve for y. Okay. So it's e to the it's y equals e to the 2 over 3 u. Oh, but u, remember, is 4x squared minus 1 to the 3 halves. So that's going to be 4x squared minus 1 to the 3, and then halves is going to be square rooting it. Okay. But then the issue is this plus c is, man, it's way up there. It's not down here, right? It's not down there. It's up there. And you're thinking, oh man, oops, I erased the wrong one. It's up here. It should be up there. And so you might be thinking, all right, well, it's none of these because it should be up there. But actually, let's take a look at this one instead, this C here, because they're tricking you on this question, I think. This plus C could be written on this side over here. Watch this. Okay. So I'm going to erase this answer. Well, no, I'm going to go like this. I'm going to leave everything. So here's my general one. ln y, right, equals 2/3 u, right? Remembering that u to the 2/3. So u to the 2/3 is just going to be, I'm just going to write that, u to the 2/3. I keep saying 2/3. I meant 3 over 2. And now that's it. Now I can add the plus c here, right? But don't do that. Add a plus natural log of c right here. They're tricking us, okay? You might be thinking, can I add a natural log of c? Yeah, you can add whatever you want. You can add 5c if you want. You can add 1,000,000 c, because then the c just scales down to whatever you want. Why do we add the natural log of c? Because then what happens is, remember that rule where it's the sum of two logarithms is actually equal to the logarithm of the product of the two arguments, all right? So this is going to be 2/3 u to the 3 halves. And now I perform my definition of logarithms. So it's going to be e to the 2/3 u to the 3 halves. So 2/3 u to the 3 halves equals yc, right? Okay. And now I'm going to alter this. I'm going to put my u back in, which is 4x squared minus 1. So it's e to the 2/3 times the root of 4x squared minus 1, all to the 3rd power, right? So this third power comes from there, and this 2 is the square root. And this is equal to y, and I can divide my c over, okay, like that. You might be thinking, well, that's not the same as this, right? You're right, it's not the same as that. So what I wanted to do instead at the very, very beginning is I want to multiply, instead of doing a natural log of c, I'm actually going to do a 1 over c, which gives me a 1 over c here, or a 1 over c here. And now instead of dividing by c, I actually can multiply by c, and bang, there I have it, the answer, or this answer here. And so, man, these guys really did a number on us here and tried to trick us because, you know, and then not only that did they try and trick us, they even went so far as to put the none of these here. So a lot of students would end up getting, I guess, this as the right answer, okay, without realizing that if you choose the right C value, you can actually manipulate it such that it looks like this one and not like this one. All right. And then another thing that a lot of students would do with this, that would mess up, is they would kind of not write this C down. They would do the definitional logarithms, and then at the very end add their C here, which is why this one comes in, okay? And then this one here is the correct answer if you forget the C completely, right? So that's why, you know, man, they were really tricking us. This is if you forget the C completely. This is if you solve for Y and then add C. This one is none of these, because this answer, the actual correct answer, is silly. It's just silly because, you know, it's just silly what they did here. Anyway, interesting question there. So yeah, I wanted to go over a couple of those differential equations. Do we have one more? No, we do. We got one more. Let's go with that one. So it says a population grows exponentially according to the differential equation here given. Okay, where P is the population, T is time, K is a positive constant. If P of 0 is A, what is the time for the population to triple its initial value? Okay, now, what is the time? Okay, look, what I do with these ones, generally speaking, is I oftentimes don't work in the differential equation here. Strangely enough, I work in the sort of grade 12 kind of exponential function, which I guess looks like this. P equals PO e to the KT. And you guys are probably familiar with this. This is the exponential growth decay function. Okay. Now, here I'm going to triple. My population is going to triple, meaning over here, after a certain amount of time, right? After a certain amount of time, T, my initial population, PO, or in this case, A, I guess, is going to be 3 times that. So I can change this to 3 times PO equals PO E KT. And I can now solve for the time. All right. Well, this is nice because look, if I divide this PO over, I'm going to end up getting 3 equals E to the KT. Now, again, if I do the definition logarithms here, definitional logarithms, this is going to be the natural log. I'll probably have to use a different color here. I'm going to use pink. So I'm getting into the dark area here. natural log of 3 equals kt. Now, if I divide by k, my time is the natural log of 3 over k, which is this guy. Oh, looks like I do have one more. 7. Choose the appropriate table for the differential equation. Okay. So for these differential equations, basically dy dx is going to be this guy. Now I'm going to choose a couple of x and y values that are found on the table. So I'm going to choose, for example, 1 and 2, right? 1 and 2, 1 and 2. All right, so I'm going to do 1 and 2. So I'm going to write dy over dx is 1, or x value of 1, minus y value of 2, or -1. Okay, so that's perfect. This one works. So this one, does not work. So no good on that one. So let's cross this guy off. And this one works. So let's check out a different one. Let's see, what do we have here? 0, 1, -1, 0, 1, -1. So these are the same. I'm going to check. There's no point in checking these numbers because I'm just going to get this. So the question is now, is this one good or is this one good? So I'm going to write dy dx equals, let's see, what is my x value? It's going to be -2 minus a -4. I'm checking this one up here first. What is this going to be? -2 minus a -4, which is +2. +2, if I'm looking at that correctly. I think then this is the correct solution. Okay, that one right there. So a little bit of things on differential equations there. And yeah, I suppose I'll sign off.